Alright, so this problem's pretty fun because it has a lot of vocabulary in it. So I highlighted two big important words in this problem, isosceles trapezoid and congruent. So you're definitely going to want to take notes on this because these are going to be concepts that you're going to encounter for quite some time in mathematics, especially when you get in 10th grade with geometry. So let's break down or define the first word, isosceles. Make sure you write that down in your notebook. Alright, so isosceles, what that means is that two angles are the same. Specifically, two base angles are the same. So if I look at the base of both of these shapes here, I see that this angle and this angle, they look approximately the same, whereas this angle here and this angle here are not the same. This one on the left is a little bit bigger than this one on the right. So this shape would not be isosceles. So this one would, because these two are congruent. So congruent means the same. So the same measurement. So congruent means the same. Isosceles means two base angles are the same. And what makes a trapezoid a trapezoid? A trapezoid is when two of the sides are parallel to each other. That means that they will go on and on forever and never touch each other. So if these were lines that I extended out forever, I know that these two lines would never cross. So the top of this four-sided figure and the bottom of this four-sided figure are parallel, and because two out of the four sides are parallel, that makes this shape a trapezoid. So trapezoid, two of the four sides are parallel. Alright, so make sure you pause the video and get all of that in your notes. Rewind if you need to. Alright, so I've added some numbers into this isosceles trapezoid here, and since this one was not an isosceles trapezoid, we're just going to delete it and give ourselves some room to work. Alright, so continuing with the problem, we see that this isosceles trapezoid is composed of two congruent triangles. That means that this triangle here is the exact same size as this triangle here. The dotted lines, let's see, alright, and a rectangle. Then we have this rectangle inside here. And what we have to do is we have to calculate the area of these three pieces and then add them all together. So I'm going to start with the area of the rectangle because that formula is pretty easy to remember, right? The area of the rectangle, oh, different pen. The area of the rectangle is equal to length times width. So I can see in this problem, well, what's the length here? Is the length 20 or is the length 16? It's 16. 16 across the top and 16 across the bottom. This 20 represents the bottom length of the trapezoid, but 16 represents the length of the rectangle. So 16 times its width will be 5. So 16 times 5, where's my calculator? Is 80. Alright, so what we have here is 80, and the units were centimeters, and because this was an area, 80 centimeters squared. Alright, so that's the area of the rectangle. Now, the area of the triangle. Area of the triangle is 1/2 times base times height, or base times height divided by 2, depending on how you want to look at it. So now just focusing on the triangle, the height is still 5, and the question is, what's the base here? And I'm only given all of this all the way across is 20. So what else do we know about this length? I know this side and this side plus this middle rectangle piece, all of it together equals 20. And this here is 16. So let's see, what is that going to leave us with? Well, let's see, the whole thing's 20. If this little part here is 16, if I do 20 minus 16, that's going to leave me with 4. So does that mean that this is 4 and this is 4? No, because 4 plus 16 plus 4 is 24, and this whole thing is 20. So the whole base of the triangle is not 4. What is it? Well, remember, I had 4 left over, and that 4 has to be divided equally between this triangle and this triangle. So dividing that by 2 is 2. So this here is 2, and this here is 2. So 2 plus 16 plus 2 is 20, which is what this whole length is. So the base of both of these triangles is 2. So the area of the triangle is going to be equal to the base, which is 2, times the height, which is 5, and then I'm going to divide that by 2. So 2 times 5 is 10. 10 divided by 2 is 5. And remember our units, this was 5 centimeters squared. So inside this rectangle, we have 80 centimeters squared. Inside this triangle, we have 5 centimeters squared. And because this triangle and this triangle were congruent, I know that this is also 5 centimeters squared. So for this situation, the area of all 3 shapes added together, right? Area of the rectangle plus the area of a triangle plus the area of a triangle is going to be 80 plus 5 plus 5, which is 90 centimeters squared.